Hello and welcome to Micro Live. Today we'll be raising disturbing questions about American government trade restrictions on British companies.
We'll be showing you how complex, customised chips can now be made simply and cheaply. And with the expected launch of a new product, we have an exclusive interview with Sir Clive Sinclair. Remember him? Sir Clive will be talking about what went wrong and about his hopes for the future.
British high-technology companies are very concerned about the way in which they're being forced to comply with these United States government regulations. British firms which do not comply are placed on this list. It's called the List of Denials, and it's published by the United States government. Under US law, American firms are forbidden to trade with any company listed. Now, since many of the basic components of information technology, like chips and software, are American, British companies placed on this list find themselves forced out of business. Speaking to Micro Live this week, Philip Hughes, chairman of the leading British software company Logica, said, "This policy of the United States government is of great concern. We are increasingly worried because there are signs that the policy is being extended to cover all kinds of software and even to take in the movement of know-how across national boundaries."
Well, US law has become important to British companies because the Reagan administration wants to starve communist countries of high technology, in case some of it could be used for military purposes. To achieve this, the US government asks for precise details of all products which incorporate US technology, even down to a single microchip. Any British high-technology product containing any component which is manufactured in America has to be detailed on this form and submitted to the US Department of Commerce for their approval before it can be sold anywhere abroad.
And every such high-technology product exported anywhere in the world gets caught by the form. For example, the British company Logica had to seek approval from Washington before it could sell its teletext software to Australia. Now, this is because although the software was written in Britain, it runs on top of an operating system which was written in the United States. Before Logica is allowed to sell this piece of software from Britain to Australia, the United States demands that Logica obtains an export license from Washington. Then, and only then, can Logica proceed with the sale.
Logica, in common with all large British companies, comply with the United States because they're terrified of what would happen if they didn't. And that is that the name of the company, the name of all its directors, would appear on the list, that is, the list of denials. And once on it, all American companies are prohibited from trading with you. And of course, for most companies, that would be a sentence of death. Deprived of supplies of vital components and software, they'd inevitably go bust. In fact, most of the listed companies that we telephoned had already ceased trading, and many of their people were out of work. And yet, this list and the legislation behind it have no legal force in this country at all. It's effective because all American companies scrupulously observe it. So, if your name appears on the list, you really have become a high-tech leper.
Brian Butcher, an entrepreneur from Hampshire, found his name on the list in 1984. Since then, no American company or subsidiary of an American company in the UK will trade with him. His business has contracted to a quarter of its original size, and there's actually a warrant for his arrest in the US, which would probably lead to his spending 4 years in an East Coast jail. And his crime? Buying second-hand microchip testers from the States and exporting them from Britain to Poland. However, at that time, in 1979, it was not made clear to him that an export license was required. In fact, he says, none of the United States companies he dealt with expressed any interest in his activities at all. They were only too glad to get rid of their obsolete kit. It was only in 1981 that the Reagan administration decided to look retrospectively at all high-tech exports for the last 5 years. It was then that Butcher found himself a wanted man. Acting under pressure from America, the UK Customs brought Butcher to trial in this country. Butcher pleaded guilty and was fined, though the judge described his case as totally trivial. But although he has paid the fine, he is still on the US list of denials and is still struggling. By contrast, Plasma Therm, an American company, was found to be exporting wafer-making equipment to China, again without a US export license. But Plasma Therm was not placed on the list of denials and is still trading normally, both in this country and in the States.
At the moment, if you're in the business of buying high technology, American suppliers will make sure that you know about these export laws. In fact, the large American computer manufacturer Digital even gave a series of roadshows on the subject to its customers last year. But Digital is as wary of the US government as British companies. Asked by MicroLive if it believed that the laws of a foreign country should apply to the export of British goods from British territory, Digital replied, "It's not a matter of what Digital thinks or doesn't think. It's a matter of what Digital has to do to stay in business."
Well, what's the attitude of the British government to this bizarre situation? MicroLive spoke to a senior official at the Department of Trade and Industry, who told us,
"We have put a lot of pressure on the Americans to withdraw this totally pernicious policy, but the Americans see themselves as ruling the roost and refuse to moderate their policy at all."
Asked what British companies should do when faced with the US export regulations, the official said,
"Well, the only useful advice we can give to British companies is not to source from the United States."
But British companies have few alternatives but to buy from the States. So, at the end of the day, whatever the original intention, in practice, America is controlling the international sales of high technology worldwide.
In the world of information technology, everybody seems to want something smaller and more reliable. And if possible, they would like more features and a reduced price. The manufacturers want to make products for as little as possible, and with development costs for high-tech products being so large, the manufacturers would prefer to build their product in a form that their competitors can't copy. Now, if you're pretty certain that you're going to sell tens of thousands of products, say like this Speak and Spell, then the answer for some time has been to turn your original design of many individual components into just a couple of custom chips, and this is what these 3 chips are here. But custom chips are expensive and they take a long time to produce. So MicroLive has been looking at a new way of making these custom chips. We followed the story of one particular chip designed to work with Acorn's BBC Master Computer. Acorn were developing a product for use in an interactive video disc system. Now, the present BBC machine offers 8 standard colours, there they are, and one of the things that the manufacturers wanted to do was to widen the range of colours available. Well, we convinced Acorn to try a new process and have some of the electronic circuitry needed for this development customised onto a single chip.
We went to Texas Instruments in Bedford to find out what lay behind the process. How can customising simplify a design like this?
Well, if we take a circuit such as Acorn's video processing unit here, you'll see the traditional way a circuit would be designed is as a number of building blocks. Each one of these being an integrated circuit with a number of components within it. These range from simple logic functions through to memory elements. Customising allows us to put a number of different functions all on a single chip. And in the example here, we're replacing about 15 of these chips.
Right, with just the one?
With just the single device.
Turning those 15 chips into one is easier said than done. Believe it or not, you would need this lot. That's about 15,000 components to build up the functions we're expecting of our one custom chip. To begin the chip design, the circuit details are entered into a workstation. This is done component by component, with each connection defined by a line of text. Or in an alternative form, pictorially, giving a direct match with that original circuit diagram. Once the design is entered, TI now relies mainly on workstation software to do the rest. It checks the entire circuit for entry errors by simulating the circuit's performance. The software feeds in known inputs. The outputs can then be checked against the waveforms expected from the circuit. When Acorn's circuit is turned into a custom chip like this, it will still be made up of those thousands of components, because the chip is just a very large number of tightly packed transistors, resistors, and so on. So this design must still be converted into a component design, and this into areas on the silicon slice which will act as tiny transistors, resistors, and so on, which when interwoven together make up the working chip. These components are sculpted onto areas on the surface of the silicon slice. These areas, traditionally created using masks, are defined by exposing slice and mask to ultraviolet light. Each exposed area fixes where chemicals are to be diffused into and grown onto the surface. The final chip is made by repeating these steps many times with different chemicals. To design the chip's physical layout, it's back to that workstation, where hardware and software do the hard work once again. Each one of these tracks, drawn here in green, will be no more than 10,000ths of an inch wide on the final chip. The green here stands for aluminium conductor. The yellow areas for one type of diffused chemical, a semiconductor region. And each of the other colours stands for a different chemical layer on the chip's surface. Software now not only draws in these interconnecting layers, but also checks out its own designs for mistakes. Before the arrival of this software, many of these design stages were, until pretty recently, carried out manually. Now, all this workstation software must have replaced a lot of skillful engineers.
Not at all. Those skillful engineers are now designing at one level higher than they have been used to. The analogy is clear if we go back 15 years. In the late 60s, many engineers were designing at the transistor level. In the 70s, the advent of custom logic functions, which each of which perhaps mopped up 100 transistors, allowed the designers to build more complex systems in the same amount of time. We've now just gone one stage further, allowing designers to build with the higher level building blocks.
So much for design. Chip manufacture calls for exacting conditions and some pretty strange garb. The many interacting layers which go to make up the chip have to be very accurately superimposed one on top of the other. Until recently, the only way of doing this was with these photographic masks. It required a lot of exotic equipment. Costs quickly mount up when each mask can cost around £1,000 to make, and when each chip needs between 10 and 15 masks for its manufacture. TI, though, are now using this electron or E-beam technology to write directly to the surface of the chip, and that avoids the need for these expensive masks. The data from the design operation is fed into the E-beam system. A fast computer working at effectively 50 million instructions per second then drives the system from this data. The silicon slice, covered in a material sensitive to an electron beam, loads into a vacuum chamber. It must be accurately aligned before the electron beam is driven across its surface. The beam scans the surface, exposing areas of the slice. In this way, the areas for later chemical deposit are marked onto the chip's surface. This E-beam scanning process is carried out to an amazing accuracy. In fact, that beam is deflected to within 10 millionths of an inch, which is about the length your fingernail has grown in the last minute. What does E-beam have to offer over traditional customizing to your customers?
Well, there are two key advantages. The first is that customers can now consider and can afford to have much lower volumes than traditionally available with custom design techniques. It's now feasible to have volumes as low as just 1,000 pieces, whereas in the past, due to the excessive cost of the photomask approach, they would have required many tens of thousands to justify the overall cost of the project. But secondly, the processing is now extremely fast, with E-beam at every stage. The time taken to start from raw silicon and end up with custom chips is a matter of just 1 or 2 weeks.
John, thank you very much.
And this is it, the MicroLive chip. The cost advantages of producing a chip in this way are very interesting. Using conventional mask techniques, the initial costs are very high, although they do come down eventually with volume production. But many UK producers don't want that sort of volume, so they can't take advantage of the reduced price. But with the E-beam technology, the starting cost is much less, and low-volume production becomes a realistic proposition, putting custom chips within the reach of many manufacturers who previously considered them too exotic. Well, the other advantage is obvious. Now, this is the board with the non-custom design, and as you can see, there are so many bits and pieces on it that they've had to actually go up another story to get everything on. And then next to it is the board with the custom chip on. There it is, and you can see how much neater the layout is. Well, Acorn have great hopes for the growth of the video disc market, and now they have a cheaper chip, a neater box, and something which the opposition should find difficult to copy.
Last year, Sir Clive Sinclair sold his ailing computer business to Alan Sugar, And now we're here, here's to announce a new computer. Announce, that is, not launch. And that's at the Which Computer Show in Birmingham in just 10 days' time. The new machine is said to be lap-held, weighing 3 pounds, but not using the flat-screen technology of Sinclair's latest miniature television. But whatever it is, and whenever it arrives, will it sell, or has he lost the golden touch? In an exclusive interview with MicroLive, Sir Clive spoke about his past performance. Clive Sinclair first came to the public's attention as the inventor of a host of gadgets which were electronic firsts. The first miniature television, the first digital wristwatch, and the first pocket calculator. But it was not long before the Japanese came out with their own versions and left Sinclair without a market. In 1980, he virtually created the home computer boom with the introduction of the world's first micro to sell for under £100, the ZX80, which was soon followed by the ZX81 and later the Spectrum. Initially, these machines were in short supply, and when they did arrive, many Sinclair customers complained that they just didn't work. Is your preoccupation with producing products that are affordable, cheap, has it affected their quality?
No, I don't believe so. That's not... We, like other people, have had our problems with quality from time to time, but generally that has been because of some quirk of the marketplace. I mean, the home computer business, of course, has been a complete nightmare in terms of getting products back, not because the products had any intrinsic faults, but because the customers we were selling to were demonic in their ability to destroy cast iron, let alone computers. And so they'd plug them into everything just because they wanted to experiment, and if it went bust, they'd return it to us, and we would replace it under the guarantee. It was a bit generous, but there we are.
But, well, yes, I take that point, but every micro manufacturer faces the same problem in that respect, and yet Sinclair, of all of them, got a very poor reputation at one stage for quality control.
Well, as I say, I don't think it was the quality control. I think it was our policy of accepting back machines, no matter what the customer had done to them. We alone had that policy.
In 1981, the BBC decided to endorse a computer to accompany a series of broadcasts promoting computer literacy. Sinclair was considered as a potential manufacturer, but the BBC was worried by the reliability of his machines and the level of support he could give to their buyers. In the end, the contract went to a small Cambridge-based company called Acorn. Can I ask you about the BBC contract, which I think you were very keen on getting at one stage? Why do you think you didn't land that?
Oh, well, because the BBC had made up their minds before they spoke to us. I mean, I think that was one of the most outrageous steps in the whole home computer business. The BBC shouldn't have given a contract to anybody. But if they did do it, it should have been an open bid, and it wasn't. We said we could have made the machine they wanted for half the price that Acorn did, and they just didn't want to know. They were making a cut, and that was that.
Are you very bitter about that?
Yes, bitter is not the right word, I suppose, because I don't go around feeling bitter. But I think it was an outrageous thing to do, a very damaging thing to do, and it shouldn't have happened.
If you had landed that contract, what kind of machine would you produce?
Well, the BBC knew what they wanted. They had a sort of outline specification. We could have provided whatever they wanted.
Would that have made a big difference to the state of the game at the moment if you'd...
Well, the difference would have been that the strength of the strength of Britain as a producer would have been very much greater, because what happened was that there were we, a hugely successful business, the most successful business really in the world in this field. We are the pioneers in this field. And then suddenly our own national broadcasting corporation, world-renowned, goes against us. We were just about to sell a large number of machines in Japan, and the Japanese turned around and said, well, what's this? You're not getting the BBC contract. Obviously you can't be, as good as Acorn, which is complete rubbish. Acorn weren't competitive at all compared with us. They're a perfectly good company, but they just weren't in our league in terms of ability to deliver product. And that was extremely damaging, incredibly damaging.
In 1984, the recently ennobled Sir Clive introduced a personal computer for the business user, the QL, or Quantum Leap. It was completely incompatible with the earlier Spectrum. The QL failed to sell. The QL adverts also make references to the BBC Micro. I think you were shown leapfrogging both the Beeb and the IBM. Wasn't that a bit ambitious?
Yes, it was. But you've got to go along with the advertising agent some of the time, and some of the time they're wrong.
Is it a danger to become too mesmerised by the technology?
That's the danger, and I think that's, yes, we all of us in the industry were. We felt that more power is always a good thing. And yes, in the fullness of time, I think it is, but you've got to, you've got to have the software to go with it. It's not that we didn't have any software. The QL came with some very nice software, but realistically, we weren't giving the public a benefit to justify the additional cost.
Yes. Sinclair's fortunes sustained further damage with the launch of the C5, a three-wheeled electric car. Announced in January 1985, it failed to impress the British public, who couldn't imagine using it on busy roads in the middle of winter. The press had a field day with the
That's
C5.
right,
They
yes.
called it an electric bee day, among other things. Has that damaged your credibility at all, do you think?
Not in the B-Day market, anyway.
But seriously, as far as the bankers are concerned, has that been detrimental?
Well, yes, I expect it has, but then I don't think the sort of businesses I've always been in and the fields I go for are high risk, and bankers look to security in that sort of situation.
Aren't you dicing with financial death?
I took that risk myself entirely, deliberately. I wanted to, and it hasn't yet been a success. That's okay. That's my money, and that's what I want to do with it.
But your research continues into electric vehicles.
Very much so, and C5 hasn't been dropped. It's being test marketed in the States at this moment, and we still hope to launch it there.
The C5 did enormous damage to Sir Clive's financial credibility, and throughout 1985 he found it difficult to get money to tide him over his cash flow problems. Finally, in April 1986, he was forced to sell his computer interests to Alan Sugar of Amstrad. But undaunted, Sinclair claims to have a new computer on the way. Did it hurt selling the Sinclair name?
Not really. I mean, it's the perception of the public is swift and clear in these things. If I bring out a computer, I don't think anyone will be doubting whose computer it is, and that is what matters.
Who will the new machine be aimed at, and what does it offer?
It'll be aimed at it's. Let me just start by saying what it's not. It's not essentially a games machine. Like as with any computer, you could of course play games on it, but it's aimed at the personal computer user. It's aimed at the serious user of computers. Though I believe that many of these will be people who have graduated, if you like, on ZX81s and Spectrums. So I hope and expect that we'll be taking a lot of our old customers with us into this new world.
Apparently unperturbed, Sir Clive continues apace, with new ideas, new inventions, and even new money. But the success of a company depends on its management, and it's clear that that was never where Sir Clive's real passion lay.
It's my job in life, as I see it, to innovate. I'm not really very interested in a market once it's become mature, which is why, as I said earlier, selling to Alan Sugar made a lot of sense in terms of the home computer market, because that's a mature business which really requires skills other than the ones I have. My purpose is to innovate.
Well, since we made that film, we've learned that Sir Clive has decided not to market the C5 in the States. Now, Sir Clive made some very specific allegations there about the BBC's microcomputer project and the way in which the contract for it was awarded. I put those allegations to John Radcliffe, who oversaw the project from 1980 to 84, starting with Sir Clive's contention that the BBC should never have awarded a contract to manufacture a micro in the first place.
If you're trying, as we were trying, through a big television-based project to switch the nation on to microcomputers and to computing, you can't do it all with television. And if, in this particular subject area, obviously there's a need for hands-on experience, because the great thing about computing is that you can get your hands on a machine and learn about it for yourself.
But there were computers around. You don't have to start up a new one.
But none of the computers at that time in the market measured up to what we thought was needed and what we thought that the technology could offer.
Right. Let's move on now to Sir Clive's allegations, which were very specific. He says that it was not an open bid. The BBC had already made up its mind.
We went out to the educational world. We got a list of the characteristics that educators thought that the ideal educational micro should have. We turned that into an outline description. We wrote to 7 computer manufacturers in around November, December time, 1980. We said, we are planning to have a BBC Micro. Are you interested in bidding? 6 of them, including Clive Sinclair, were very interested in bidding. They made offers to us. We looked at those offers in detail in successive meetings of a committee of about 10 people with both BBC people and people from outside the BBC on a grid of characteristics. And we looked extremely carefully in detail at issues like what was the characteristics of the basic, how many interfaces did it have, how could it handle colour, how powerful was it, all these sorts of things. And we made a decision purely on technical grounds. The reason that Clive Sinclair's machine didn't actually get the contract was that it didn't measure up on technical grounds to what some of the other people were offering.
You say Clive Sinclair's machine, but Clive Sinclair told me that he would have been prepared to build whatever machine you wanted. He would have built a machine to your specifications.
Don't forget, we had to have a machine built within, at that time we were saying 9 months. In fact, we stretched it to a year. You had to take as your starting point something that the manufacturer already had. Now, Clive Sinclair had just produced the ZX81. He made it very clear to us, and I can document this, he made it very clear to us that he would not be able to move very far away from that specification. We were looking for the ideal educational micro on which people could learn seriously about computing. Not just play games, but actually start to understand what computers have to offer.
Even if they had to pay through the nose for it?
Well, they didn't have to pay through the nose for it because people had the option, as indeed they did in huge numbers, of buying the machines that were offered by other manufacturers, including Clive Sinclair. And in the year that followed our television series, hundreds of thousands of people bought Sinclair computers, and I think Clive Sinclair benefited tremendously from our project.
That's all for this week. Next week, we'll be showing you how the audience researchers work out how many people are sitting at home around their television sets.
We discover how one bank allows you to use your micro to look at your own bank account, and how the mains wiring can be used to carry messages around a network of red boxes. So, until then, goodbye.
Goodbye.